Thousands of years ago, Scandinavians strapped wooden planks on their feet to glide across snow. Those first skis enabled them to hunt and trap in the winter. Essentially, they skied to live. Today, however, some of us live to ski, and cutting-edge equipment is part of the appeal. In the past century, downhill skis have become shorter and curvier for peak performance. They start with the squared-off ash log. A bandsaw slices it into several planks. Ash is supple but strong, which makes it an ideal wood for the core of a ski. A second blade thins each plank at the end and widens it where the skier's foot sits. Sanding establishes subtle angles on the edges. Then the planks move along to a machine that cuts teeth into them. A ridged applicator applies epoxy glue to the toothy ends of two boards. Machinery presses them together for a tight fit, and as the glue dries, it creates a permanent bond. The two planks are now one ski core. It still needs some fine-tuning, so a robot positions it on a conveyor, which takes it under a sanding belt. It smooths the interlocked section and grinds deep side cuts into the core. This defines the parabolic shape that helps skiers carve through powder in short, clean turns. They silkscreen graphic artwork and logos onto plastic. It's a bit of corporate PR, but the flashy designs can also inspire the skier. An operator then brushes a release agent into a mold as she prepares to build and shape several skis at a time. A little vacuuming gets rid of any dust that would sully the work. Then she tucks pieces of graphite-fortified polyethylene into the mold. They will form the base of the skis. She places rubber on the ends to minimize vibrations while skiing. Next come layers of special fiberglass that run the length of each ski. This material is both flexible and durable. It's been formulated specifically for skis. The weave varies from layer to layer, depending on the type of ski. Strips of rubber reinforce the back ends, followed by pieces of heavy-duty polyurethane. The assembler places the curved wooden cores on top of the synthetic layers. She installs melamine to build up the ski's sidewalls. This improves gripping in hard snow. To provide a firm base for bindings, she covers the narrow waist of the ski with more fiberglass, followed by an aluminum plate to hold the binding screws in the ski. More layers of fiberglass follow, imbued with epoxy glue, which is about to be activated. Once the colorful top sheet is secured, they close the mold. Inside, the temperature reaches 100 degrees Celsius. This causes the glue impregnated in the fiberglass to liquefy, while the mold squeezes the layers into the shape of the ski. When the glue hardens, the many layers become one solid ski. It's a fusion of synthetic materials, wood, and metal. But it's still a bit rough around the edges. So this robot smooths the tip and tail of the ski against a sanding belt. The ski then travels over several grinding wheels. This cleans it up and creates angles for precision carving on the slopes. Then, like a powerful fist, this machine tests its flexibility and strength. Finally, a worker screws a rail system to the waist of the ski to make it easier for the ski shop to install bindings. Then, it's all downhill from here, which of course is the whole idea. Fog and blinding snow can obscure the view from the top of a ski mountain, but a good pair of ski goggles can add some clarity to the situation. They shield the eyes from the elements, and certain lenses add contrast in low light to allow the skier to see the bumps and dips ahead. Goggle lenses come in different tints to adjust for specific weather scenarios. They start with this injection molding machine. The operator sprays a non-stick substance into the mold and closes the door. The machine sucks up urethane pellets, then melts them into a thick liquid to mold into goggle frames. It takes just seconds for the shape to harden. A worker clips away unwanted bits, and then he's ready to give these goggles a more graphic look. He immerses the cellophane-like film, printed side down, in a mix of water and solvent. A chemical reaction lifts the graphic design off the film and suspends it in the liquid. He sprays solvent on the other side to both activate a bonding agent and dissolve the film. He then immerses a rack of goggle frames in the floating graphic. The surface tension of the water causes the graphic pattern to wrap around the frames, and the bonding agent makes it stick. This technique is called hydrographics, and it's a good way to transfer a pattern onto a three-dimensional surface. He washes away any paint or dirt from the surface of the frames. A clear lacquer is the finishing touch. For an understated look, there's always monochromatic white. A worker applies glue around the vents of a pair, then presses foam onto them. The foam will keep snow out of the goggles, but allow air to be vented to prevent fogging. He applies thicker foam around the perimeter for a weather-tight fit on the skier's face. Once the straps are installed, the goggles are ready for the latest innovation, a microelectronic fan. It will pull warm, humid air out of the goggles to further prevent fogging. He screws the mini fan to the frames and listens to its spin to confirm it's operating correctly. Next, a machine cuts shapes out of polycarbonate to make lenses. Then the special press applies heat to bend the lens. This shape will make it easier to secure the lens to the frame, and it also reduces optical distortion. Production now moves to this liner-backed foam with pre-cut lens patterns. The worker peels off a strip to expose a goggle-shaped strip of foam. She then presses a colored lens onto the strip. High-strength adhesive on the foam bonds to the lens. She pulls away the rest of the material, leaving that narrow ribbon of foam. It will serve as a spacer between the outer colored lens and an inner clear one. The space between the two lenses is a buffer zone to prevent condensation buildup and fogging. Now they shoot a steel pellet at a randomly selected pair of goggles. It doesn't shatter, which means it will effectively shield the skier's eyes from sharp objects like tree branches and ski poles. It's time to snap the dual-layer lens into the frame's molded groove. A UV mirror coating has also been applied to protect the eyes from the sun's rays and reduce glare. These goggles have everything covered, leaving the skier free to focus on the thrill of the ride.